In this video, we will be showing how to spot a common adulterants and substitute of cannabis. We have here different and diverse botanical samples to differentiate and evaluate according to its serration patterns, venation, and leaflet structure. First sample that we have is the eggplant leaf, bitter gourd leaf, the lady's finger leaf, camphor leaf or the gabon leaf, and lastly the papaya leaf. We will be examining them according to its adductal or the upper surface of the leaf, and according to its subaxial, refers to the lower surface of the leaf. But before proceeding to the examination of the samples, let me first introduce to you the proper PPE attire or the personal protective experiment attire. First, we must wear a gloves. It prevents cross-contamination of samples and protect the skin from hazardous chemicals that can cause burns or rashes. Secondly, we must wear a laboratory gown. It acts as a primary barrier, protecting skin and personal clothing from contamination. Next, we must wear a face mask. It prevents personnel from inhaling hazardous particles, and they provide a barrier against liquid splashes, reducing the risk of respiratory infections. We also need to wear a safety laboratory goggles. It is to protect our eyes from chemical splashes, hazardous fumes, and intense lights. To examine and to identify the different diverse botanical samples, we will be using a different kinds of materials. First, we have here a yarn. This is useful in naming and identifying parts of the species. We also have here a ruler. This is used to measure the width and length of the sample. We also have here the push pins. And we have here a petri dish. Inside of it is an unknown sample that we will be using as a basis to compare the different botanical samples. And we also have here the medicinal dropper. It is used to extract an exact amount of solution. And we have here a forceps. This is used to move and hold the specimens, avoiding direct hand contact. We have here also a scalpel. It used to cut and help prepare the samples. And we also have here liquid solution, the saline solution, and diluted HCl. These liquids are important to confirm the presence of trichomes and how the samples would react to chemicals. We have here a huge piece of glass. This is used to flatten the surface of the leaf. Lastly, we have a compound microscope. This is important so that we can see thoroughly the parts of the leaf. Upon subsequent test has done, we can now conclude the elimination of some samples, namely the eggplant leaf and the camphor leaf, due to its leaf type, categorized as a simple leaf type that cannot be identified from the said unknown sample.
Among the leaves tested, papaya, eggplant, bitter gourd, gabon, and ladyfinger leaf. Ladyfinger leaf, or the Abelmuscus esculentus, was found to be the most likely substitute for Cannabis sativa due to its closer similarity in leaf shape, venation pattern, and overall morphological structure compared with the other samples. While papaya, or the carica papaya, eggplant, Solanum melongina, bitter gourd, Momordica carrancha, and gabon, Gynora bicolor, showed distinct differences in leaf form and surface characteristics. The ladyfinger leaf displayed lobed features and venation patterns that more closely resemble those of cannabis, making it the most probable visual substitute among the specimens examined. The leaves underwent several examinations, labeling, to properly identify and organize each sample, measurement, to record leaf length, width, and lobe characteristics, elimination, where leaves with clearly different morphological traits were excluded, and finally, the microscopic examination, to observe cellular structures such as trichomes and epidermal patterns. Through these procedures, the ladyfinger leaf was determined to be the closest substitute for cannabis among the tested leaves.